Good morning, you guys. It's Miss Silva. Welcome to another week. We are taking a look this week at using our exponents and our radicals, putting them together in some geometry. We're going to take a look at Pythagorean theorem. Pythagorean theorem works with triangles, right triangles. So what we're going to do, taking a look at the notes outline, we're going to take a look at a pattern of a small square, a medium square, and a large square to decide if those three lengths are going to create a right triangle or not. And what I'm going to do before we actually start that is take a look at this YouTube video right here. So you can see that we've got a small square right here. You can see we've got a medium square right here and a large square right here. So again, Pythagorean theorem, we're looking to see if we take a look at the two smaller squares, is it equivalent to the same space in the big square? So the small square and the medium square that are squared up off of each side of the right triangle are pouring in to the large square that's off of the longest side of the right triangle there. We know it's a right triangle because we can see that right angle notation. And then again, just kind of pouring it back in to show that no liquid was added, none was taken away. So again, just kind of a nice visual as we start to take a look at the Pythagorean theorem. So if we consider, again, a right triangle. So again, we know it has to be a right triangle. So we know that we need to see that little notation of a right angle in the corner there. And then we're going to be given some side lengths of the triangle. So in this triangle, 3, 5, and 8. So we're going to decide if we take the smaller and the medium square, just like we looked at up here, and take a look at the area of each of those, does it give us the area of the larger square? So remember that to find the area of a square, we're going to take and multiply the length by the width. And so since it's a square, we know the length and the width are exactly the same size. So the area here, 9. The area here, 5 times 5 is 25. And the area here, 8 times 8, that gives us 64. So again, the question is, if we take the smaller square and add it to the medium square, does it give us the same amount as the larger square? So we can see in this case, 34 does not equal 64. So in this case, this is an answer of no. These three sides do not make a right triangle. Let's check the next one. So 3 times 3, again, length times width is 9. 4 times 4, length times width, that's 16. 5 times 5, the length times width, that's 25. So if we add the small square and the medium square, does that give us the same amount of space as the larger square? 9 plus 16 is 25. So in this case, absolutely, it does. This does give us a right triangle. So again, we're looking for these yes/no answers. Sorry, let's see if we can get the document camera to focus a little bit better. So this is not a right triangle. This is yes, it is a right triangle. And let's take a look at one last one. 4 times 4 for that square. 6 times 6 for that square, and then the larger square, 8 times 8, 64. So again, if we add the small and the medium, does that give us the larger one? 52. So in this case, it does not work. So again, no, this one is not a right triangle. So here's where, this is what we're doing. We're checking to see if these side lengths give us a right triangle. So what we're told in the next set of questions is that we have a right triangle. You can see that drawn in there. And just like in the video that we started out watching, you can see from each side of the triangle, there's a square that's been drawn out. Now they've already done the multiplication to tell you the area of the small square is 9. The area of the medium square is 34. We need to figure out the area of the larger square. So again, the multiplication has already been done for us. So we've got the small plus the medium. Again, those have already been calculated for us. The areas have been done. We can see that squared notation there. Equals the large one. We'll go ahead and call that x. So 9 plus 34 is 43 square centimeters for that larger one. So again, when we see that those units have been squared, that means the multiplication has already been done for us. The area of this small square is 8. The area of this medium square, 12. And adding those together is going to give us the area of the larger square, which is, in this case, 20 square meters. And finally, this one, a little, oops, sorry, scoot that up some, a little bit different. Again, remember we were saying that the small square plus the medium square equals the large square areas. Small area, medium area, large area. So the small square area is 10. The medium square, we don't know what that is, so I'm going to call that my unknown. And then we'll go ahead and write down our larger one, 25 there. So a little bit of opposite operations to solve this one. So x, which is our medium square, has an area of 15 square feet. Okay, so the relationship that we've discovered between the sides of these right triangles is called the Pythagorean theorem. So again, Pythagorean theorem, it allows for us to determine if a triangle is a right triangle. It could be just another one. It could be a scalene triangle, an obtuse triangle. It could be an acute triangle. But this is for us to be able to check to see if it's a right triangle. And so if we have our small side, again, let's call this small side A, I guess. And we'll call this medium side B and this large side C. The area of the small square, so that's A times A. Again, we would think about, drawing out our squares here so that we would have A times A. And then B, again, we can kind of think about drawing a square out from there, B times B. And then from our largest side, C times C. So we can simplify this a little bit. We don't have to use as many letters. A times A using our exponent rules is A squared. B times B, that's B squared. And then C times C is C squared. This is very common of what you would see. Pythagorean theorem is A squared plus B squared equals C squared. So let's go ahead and apply that to this example right here. Again, we've got 3 sides. So one of the key things to remember is that the largest side of a right triangle, this is super important, largest side of a right triangle is always across from the right angle. So knowing that it's across from the right angle, that means that we can take for any of these right triangles, find that right angle. Across from that, here's our largest side of our triangle. So that's going to tell us that this is always going to be that value for C. And then the other two sides, sorry, I'm going to refocus this real quick, see if it'll focus in. There we go. That's a little bit better. So then that means the other two sides, we can compare them. So we can say this is smaller, this is medium, and then this is large. Okay, so that helps for us to figure out which values are here. So the small side, 5 squared, plus the medium side, that one's x, so x squared, equals the largest side, 13 squared. So again, above they did this multiplication for you, and they already did that multiplication, put the units squared. We need to actually do the multiplication here. 5 squared is 25. X squared will leave. 13 squared, you can pull out your chart from the notes that we did last week. That's 169. To solve this equation, we'll use opposite operations. Subtract 25 from both sides. And that's going to give us x squared equals 144. And then again, from last week when we were working with our exponent rules and our radicals, we know that to undo something that is squared, we're going to go ahead and do the opposite operation, which is square root. Sorry, I'm going to try to refocus this one more time. There we go, that looks better. So again, we're going to go ahead and square root both sides. And so that gives us the answer x is equal to 12 and negative 12. Now remember, when we take a look at solving a squared equation, we get two answers, the positive and the negative. But really what we need to do is look at this and say to ourselves, can this really be a side length? Okay, so can you actually measure negative 12 on a ruler? Can you be negative 12 units on a triangle? And that answer is no. So we will never consider the negative value of that, solving that equation. So it'll just always be the positive answer there. So we would answer that the missing side of our triangle is 12 centimeters. So the second page of our notes is just going to be a little bit more practice with each of these. So what we'll do is we'll take a look again. If we were in class, we would go through more, maybe assign these to be solved in groups, but for now we'll just take a look at a few examples. Some of these numbers, as we go through and square them, you might be familiar with knowing what 5 times 5 is. Some of the numbers that we'll work with might be really too large. I'm going to go ahead and move this sheet now. So a calculator is definitely going to be appropriate for some squaring or for some square root work that we might need to do. So let's go through and take a look at a few of these examples. Okay, so again, we're going to go through and work just a few of these. So I know that my largest side is always across from my right angle. So this is always going to be the value for C. Okay, now you can see that for the missing sides, they've put in some variables, some X's, K's, W's, Y's. It really doesn't matter what variable we use as long as we're representing it as an unknown. Okay, so I'm going to go ahead and say this missing side, that's my smaller side. The medium side, 8, and the largest side, 10. Okay, so we need to square each of those. 64, 10 squared is 100. Solve the equation. Oops, sorry. Brain working a little bit too fast there. Subtract 64 on both sides, and that gives us 36. And then we will square root both sides. And that gives us our answer. Remember, we're only using the positive answer, which is 6 inches. Let's take a look at example B. So again, here's my right angle. Across from that is my unknown. So this is going to be my value for C. So I've got my small side, medium side, and the large side. That's the one that's unknown. Whether, again, I said whether you use C or whether you use X, it doesn't matter just as long as it's a variable. Oops. C squared there. So 9 plus 16 is equal to 25. And then we'll go ahead and square root both sides. And that gives us a value of 5 centimeters for our longest side. Example C, you can tell that these numbers are a little bit larger here. I'm going to scoot this over for just a second. There we go. Okay, my right angle across from that is my side C. So here's my smaller side, medium side, and the longest side. So I don't know what these numbers are squared, so I'm going to go ahead and plug it into the calculator. 24 times 24 is 576. And then 25 times 25 is 625. And then we'll do our subtraction on both sides. And it gives us 625 minus 576 is 49. And then we'll go ahead and square root both sides. And that gives us 7 meters. All right, so let's take a look at just a couple more. We'll take a look at D and E. So again, no matter how our triangles are situated, the longest side is always across from that right angle. So that's why I always kind of take that right angle and go capture that side across from it, so I can tell what my smaller side and medium side are. So that's 64 plus k squared. 17 squared. Let's plug that into the calculator. 289. And then we'll subtract 64 on both sides, which leaves us with 225. And we'll square root both sides. The square root of 225 is 15 feet. Okay, so these numbers are working out really quite nice. They're nice, perfect. When we take the square root, it won't always be the case. We might end up that if it's not a perfect square, we'll have to plug that into the calculator. We might see that a little bit later. We'll take a look at this one as our last example. So the smaller side 9, medium side W, largest side 41. Again, we want to remember that we square those sides. 9 squared is 81. 41 squared, 41 times 41, 1681. Subtracting 81 on both sides, that gives us W squared equal to 1,600. And when we take the square root of that, let's see, on your calculators you're going to see that you guys have a square root button. On my calculator that I have here, it's this one right here above my x squared. So let's see, the square root of 1,600. You might have to put in 1600 and then hit your square root button. Just kind of varies with calculators. And that gives us an answer of 40 kilometers. Okay, so there were a few more examples there that we didn't get to, but I think that we went through enough to kind of give you a idea on how to solve these. We will continue with one more set of notes for this week in just a little bit. Hope you guys have a great day.